So this fraction is top heavy. So we need to remember that a fraction is the same as a division. So 8 over 3 is the same as 8 divided by 3. So when we want to convert 8 over 3 or any improper fraction into a mixed number, we need to say 8 divided by 3, or how many times does 3 fit into 8? So what we can do is a little division in our division house. We can say that 3 fits into 8 twice, and 2 times 3 is equal to 6, and the difference between 6 and 8 is 2. So we know that we have got 2 wholes. 3 fits into 8 twice, and we've still got a remainder of 2. Now that remainder of 2 still needs to be divided by 3, so that remainder of 2 acts as our new numerator. So 8 over 3 into a mixed number is equal to 2 and 2/3. Now, how we can do that in a slightly easier way is just to say how many times does 3 fit into 8, and we can do that mentally if you'd like. So 3 into 8 goes twice, so there's our 2 wholes, and then in your head you can say 3 times 2 is 6, the difference between 6 and 8 is 2, so there's your new numerator, and your denominator will always stay the same. So your denominator in your improper fraction and in your mixed number will always stay the same. Right, let's have a look at another example. 14 over 5 is equal to 5 into 14 fits twice, and 5 times 2 is equal to 10. The difference between 14 and 10 is 4, and then our denominator will always stay the same. Right, if we have a look at 90 over 8, we know that 90 and 8 are both even numbers. So we can divide both these numbers by 2 to get 45 over 4. So these are equivalent fractions. So now I'm working with smaller numbers here. So I can obviously work with this a little bit more easily than I could with this one. And then it also means that I don't have to simplify my mixed number at the end. So 45 over 4, 4 into 45 fits 11 times with a remainder of 1 over 4, because 4 times by 11 is equal to 44, and the difference between 44 and 45 is 1. Right, so if we were to convert 90 over 8 into a mixed number, 8 fits into 90 11 times, so we still have our same whole number, and 11 times 8 is 88, and the difference between 88 and 90 is 2, so we've got 2 over 8. We now need to simplify this common fraction there, because our whole number will stay the same, but 2 over 8 can be simplified down to 1/4. So as you can see, we end up with the same answer. Right, let's have a look at 25 over 6. 25 over 6 is 25 divided by 6. So how many times does 6 fit into 25? It fits in 4 times with a remainder of 1 over 6. Because 6 times 4 is 24. The difference between 24 and 25 is 1. Right, let's have a look at one more. 45 over 7. 7 fits into 45 6 times. 6 times 7 is equal to 42. So the difference between 42 and 45 is equal to 3. So we've got 3 over 7. So 45 over 7 is equal to 6 and 3 over 7 as a mixed number. Six and 2 over 3 is equal to is a mixed number. So if we would like to see what 6 2/3 is equal to as an improper fraction, what we need to do is we need to multiply our whole number by the denominator, and once we've got the answer to that, we plus the numerator, and that will give us our new numerator. And remember that with both improper fractions and mixed numbers, your denominator will always be the same. So our denominator will definitely stay as 3, but in order to find our numerator, we need to say 6 multiplied by 3, which is equal to 18, and then 18 plus our 2 to get our numerator is 20. So 6 2/3 is equal to 20 over 3. If we have a look at 1 3/5, we need to multiply our 1 by 5 to get 5, and then plus so we multiply 1 by 5 to get 5, plus our numerator to get 8. That is our new numerator, and then our denominator will always just be the same. So our denominator stays as 5, so 1 3/5 as an improper fraction is equal to 8 over 5. Seven 8/9, we need to multiply our 7 by 9 to get 63, and then we have 63 plus 8, which is equal to 8 plus 3 is 11, and 6 plus 0 plus 1 is equal to 7. So we have got 71 over 9. So 7 times 9, or 7 8/9 as an improper fraction, is equal to 71 over 9. Three 8 over 11. 3 multiplied by 11 is 33, and then we plus our 8. So 3 plus 8 is equal to 11. 3 plus 1 plus 0 is equal to 4. So we end up with 41 over 11 because our denominators will always stay the same. Nine 2/5. 9 times 5 is equal to 45. So 45 plus 2 is equal to 47. So our answer is 47 over 5. When we are converting from mixed numbers into improper fractions, so if we convert 1 8 over 9 into an improper fraction, we will see that we can then check whether that improper fraction, when we convert it back into a mixed number, will give us this same answer. So let's have a look. 1 times 9 is 9, and 9 plus 8 is equal to 17. So that's 17 over 9 because our denominators stay the same. So now if we would like to convert 17 over 9 back into a mixed number, so we've got 17 over 9, 9 fits into 17 once, and we've got 8 remaining over 9. So as you can see, this mixed number and this mixed number are the same, which means we did convert our mixed number into an improper fraction perfectly. Let's have a look the other way around. So if we've got 27 over 5, let's convert 27 over 5 into a mixed number. So 5 fits into 27 5 times. 5 times 5 is 25. The difference between 25 and 27 is 2. And we've got 2 over 5 because our denominators stay the same. So now let's convert our 5 2/5 back into an improper fraction. So So we say 5 times 5 is 25. 25 plus 2 is 27. And then we've got our denominator, which stays the same. So we end up with 27 over 5, which is what our original improper fraction was as well. Which means we converted our improper fraction into a mixed number perfectly. Let's have a look at 60 over 9. 60 over 9, firstly, can be divided by 3. Can be simplified because we can divide both 60 and 9 by 3. So 60 divided by 3 is 20. 9 divided by 3 is 3. So 20 over 3 is equal to 3 into 20 goes 6 times. 6 times 3 is 18. The difference between 18 and 20 is 2. So we end up with 2 over 3. Right, so 6 and 2 over 3 as a mixed number. Let's see if we end up with the same improper fraction that we started with. So 6 times 3 is equal to 18. 18 plus 2 is equal to 20. And then we have 20 over 3. So as you can see, we converted our improper fraction into a mixed number perfectly because we ended up with the same improper fraction that we started off with. When we are adding fractions, we are only able to add them once we have our denominators equal to each other. So our denominators need to be the same before we add or subtract our fractions. So with fractions, as soon as we've got our denominators to be the same, which they are here in 2 over 3 and 1 over 3, our answer will have the same denominator. So as soon as our denominators are the same, 3 and 3, we know that we are going to have a denominator of 3 in our answer as well. So we've got 2 over 3 plus 1 over 3. So because our denominators are already the same, all we do is we plus our numerators. So 2 plus 1 is equal to 3. So we can have a look. So 3 over 3 is obviously equal to 1 whole. So we can have a look at this just block that we've divided into 3 equal parts. So we had originally 2/3 over there, and we were adding 1/3. So there is our 1/3. And as you can see, 2/3 plus 1/3 will give us an answer of 3/3 or 1 whole, because it ended up filling up our entire block. Right, so when we are working with fractions that do not have the same denominator, so if we are going to add 2/5 and 3/8 together, what we need to do is find a common denominator. So because we know that 5 and 8 will have a common multiple, we need to try and find their lowest common multiple. So we can count in 8s until we get to a multiple of 5. So we start with our bigger number 8 because we should count fewer numbers before we get to a multiple of 5 than if we were to count from our smaller number first. So if we count in 8s, we've got 8. 5 does not fit into 8, so 8 will not be our lowest common multiple. 8, then 16. 5 does not fit into 16. Then we've got 24, no. Then we've got 32, and then we've got 40. So we know that 5 fits into 40. So our common denominator is going to be equal to 40. Now we need to think, what did I do to my 8 to get 40? I multiplied it by 5. And what did I do to my 5 to get 40? I multiplied it by 8. And therefore, Whatever we do to our numerator, we have to do to our denominator, and whatever we do to our denominator, we have to do to our numerator. So because I times 5 by 8 to get 40, I need to multiply my 2 by 8 as well, and I end up with 16. So 16 over 40 is now equivalent to 2/5. 8 multiplied by 5 gave me 40, so I need to multiply my 3 by 5 as well to get 15. So 16 over 40 is equal to 2/5, and 15 over 40 is equal to 3/8. Now, because our denominators are the same, we know that 40 is going to be the denominator in our answer as well. And all we need to do now is plus our numerators. So 16 plus 15 is equal to 31. And 31 over 40 is our simplified fraction. So 2/5 plus 3/8 will give us an answer of 31 over 40. Right, let's have a look at 3/4 plus 5/6. So we now need to find a common denominator, or a LCM, or lowest common multiple, between 4 and 6. So let's count again in sixes, because 6 is our bigger denominator. So 4 does not fit into 6. 12, 4 does fit into 12. So 12 will be our LCM, or our lowest common multiple, or our common denominator. So now I need to ask myself, what did I multiply 4 by to get to 12? I multiplied that by 3, so I need to multiply my 3 by 3 as well. So 3 by 3 is 9. So 9 over 12 is equivalent to 3 over 4. What did I multiply my 6 by to get 12? I multiplied it by 2. So 6 times 2 is 12. So 5 times 2 gives me 10. So 5 over 6 is then equivalent to 10 over 12. So now I've got 9 over 12 plus 10 over 12. So I know that my denominator is going to be 12. And then I plus my numerators. So 9 plus 10 is equal to 19. And I end up with an improper fraction, which is fine. So that is the correct answer. But if I would like to convert my improper fraction into a mixed number, which is probably better because perhaps your teacher would want you to leave it as a mixed number, we say 12 fits into 19 once, and there's a remainder of 7 over 12. So your answer is 19 over 12, or 1 and 7 over 12. When we are adding or subtracting mixed numbers, it's best for us to convert our mixed numbers into improper fractions before we add or subtract. So when we are adding, we can actually first add our whole numbers and then add our fractions. But because we cannot really do that when we are minusing, we can do it, but it gets much more complicated. So it's much better for us to just convert all our mixed numbers into improper fractions before we do any of our calculations. So 1 and 1/4 is equal to 1 times 4 is 4 plus 1 is 5 over 4, and then we plus 2 times 3 is equal to 6 plus 1 is 7 over 3. So now we've got 5 over 4, which is equivalent to 1 and 1/4, and 7 over 3, which is equivalent to 2 and 1/3. So we now need to find a common denominator, or an LCM, between 4 and 3, which we will find is 12. So what did I do to my 4 to get 12? I multiplied it by 3. What did I do to my 3 to get 12? I multiplied it by 4. So I need to do the same things to my numerators. So 5 times 3 is 15, and 7 times 4 is 28. So I know my denominator is going to be 12, and I can say 15 plus 28 on the side, just to be sure. And 5 plus 8 is 13, and then I have 4. So 43 over 12 is my answer. And 43 over 12 is an improper fraction. So to convert 43 over 12 into a mixed number, we say 12 fits into 43 3 times, and 3 times 12 is 36. So the difference between 43 and 36 is equal to 7. So we have 3 and 7 over 12 as our mixed number. So 1 and 1/4 plus 2 and 1/3 is equal to 43 over 12, which is equal to 3 and 7 over 12. Let's have a look at what would happen if we first added our whole numbers and then added our fractions. So 1 plus 2 is equal to 3, and then 1/4 plus 1/3. So we remember to plus our 3 wholes at the end, but for now we just say 1/4 plus 1/3, and we get a common denominator of 12, or LCM of 12, and then we multiply our numerators by whatever we multiplied our denominators by to get 12, and we end up with 3 and 4. So 3 plus 4 is equal to 7, and then it's over 12, and we remember to say 3 plus 7 over 12 is equal to 3 and 7/12. So as you can see, we end up with exactly the same answer. So when we are adding mixed numbers, you can first add the whole numbers and then add the fractions separately, as long as you remember to add that whole number at the end. But also, if you remember that it is only when we are plussing fractions that you can do this, because when we are subtracting fractions, when we are subtracting mixed numbers rather, it becomes much more complicated when we first deal with our whole numbers. So when we are subtracting with mixed numbers, we rather convert each of the mixed numbers into improper fractions before we subtract. So it might just be a good idea to get into the habit of doing that when we are adding mixed numbers as well. When we are subtracting fractions, we again need to find a common denominator. So we need to find the LCM, or the lowest common multiple, between our denominators. So the LCM between 9 and 6, we need to first work with our bigger denominator and count in 9s until we get to a multiple of 6 as well. And that will be our LCM. So 6 does not fit into 9, so 9 is not our LCM. Then we've got 18. 6 does fit into 18, so 18 will be our LCM. So we multiplied 6 by 3 to get 18, so we need to multiply our 1 by 3 as well. So 1/6 is equal to 3 over 18, and we multiplied our 9 by 2. So we need to multiply our 8 by 2 to get 16. So 8 over 9 is equal to 16 over 18. Now that we have a common denominator, we know that 18 is going to be the denominator in our answer as well. And then we just minus our numerators. So 16 minus 3 is equal to 13. So 8 over 9 minus 1 over 6 is equal to 13 over 18. Let's have a look at mixed numbers. So if I've got 1 and 2/5 minus 3/4, 1 and 2/5 minus 3/4, as you can see, we've got a mixed number here. So we need to convert our mixed number firstly into an improper fraction before we go any further. So 1 multiplied by 5 is 5. 5 plus 2 is 7. So we've got 7 over 5. So 1 and 2/5 is equal to 7/5. And then we minus our 3/4. So now we need to get a common denominator between 5 and 4. So 5, let's count in our 5s until we get a multiple of 4 as well. So 5, 10, 15, 20. 20 is the first number in our 5 times table that is also a multiple of 4. So 20 is going to be our common denominator. So we've got 4 times 5 is equal to 20. So we multiply our 3 by 5 to get 15. And 5 times 4 gives us 20. So we multiply our 7 by 4 as well. So 7 multiplied by 4 is 28. So 7/5 is equal to 28 over 20. Right, so now that we know that 20 is our common denominator, we know that 20 will be our denominator in our answer. And then we work out 28 minus 15 on the side, just to be certain. 8 minus 5 is 3. 2 minus 1 is 1. So we end up with 13 over 20, and that is our simplified answer. So 1 and 2/5 minus 3/4 is equal to 13 over 20. When we are working with of, we need to understand that of is the same as a multiplication. So when we are working out 2/3 of 18, we can say 2/3 times by 18 over 1. And then we can cross cancel. So 3 fits into itself once, 3 fits into 18 6 times. 6 times 2 is equal to 12, and 1 times 1 is equal to 1. So 12 over 1 is equal to 12. So 2/3 of 18 is equal to 12. Another way that we could have worked 2/3 of 18 out is 2/3 of 18. What you do is divide. So you say 18 divided by your denominator, and then you multiply that answer by your numerator. So 18 divided by 3 is equal to 6, and 6 times 2 is equal to 12. So this works nicely when we are working with whole numbers. So let's have a look at 5/6 of 42. 42 divided by 6 is equal to 7. So that's equal to 7. Then we need to multiply our 7 by 5, and that gives us an answer of 35. So 5/6 of 42 is equal to 35. Let's have a look at 3/7 of 56. 56 divided by 7 is equal to 8, and 8 times by our numerator, which is 3, is equal to 24. So 3/7 of 56 is equal to 24. Two over 3 multiplied by 3 over 5. Right, when we are working with fractions and when we are multiplying fractions together, what we need to do is quite different to what we do when we are adding and subtracting fractions. We do not get a common denominator, so that is very important. So when we are multiplying fractions, all we do is we times our numerators together and we times our denominators together, and then we simplify. So 2 times 3 is equal to 6. 3 times 5 is equal to 15. And 6 over 15, we can divide both these numbers by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. So 2/3 times 3/5 is equal to 2/5. Right, so let's have a look at another option. 2 over 3 times by 3 over 5. We need to try and see if we can firstly simplify each individual fraction, which we can see that we can't because 2/3 is the simplest form and so is 3/5. And now what we want to try and look out for is whether or not we can cross cancel. Now cross cancelling, what we can do is the multiplication sign helps us because it almost points to the numbers that we must consider. So firstly, we look at this, it's pointing to this 3 and to this 3. So this numerator and the opposite denominator, we see whether we can simplify between those two numbers. So that is called cross cancelling. So we see whether we have a common denominator there, which we know we do because 3 fits into 3 once and 3 fits into 3 once as well. So then we have a look at our 2 because we've got an arrow pointing at our 2 with the same line pointing at our 5. So we see if there's a common denominator, a common factor between 2 and 5. And there isn't. There's no common factor between 2 and 5, so we just leave those the same. Right, so we end up with 2 multiplied by 1, which we can see is equal to 2. And 1 multiplied by 5 is equal to 5. So as you can see, you end up with the same answer, 2 over 5. Right, let's have a look at 6 over 7 multiplied by 1 over 4. So what we can do is say 6 times 1 is 6. 7 times 4 is equal to 28 because we're just multiplying our numerators and then multiplying our denominators. So 6 over 28 we can simplify. Let's divide them both by 2. So 6 divided by 2 is 3 and 28 divided by 2 is 14. Right, now let's have a look if we can simplify. So let's look at our 7 and our 1, cross cancel. So let's have a look at our 7 and our 1. We know that we cannot cross cancel 7 and 1 because there's no common factor between those numbers. Then let's have a look at our 4 and our 6. So 6 and 4 do have a common factor of 2. So we can divide the 6 by 2 to get 3. And we divide our 4 by 2 to get 2. And then we can say 3 times 1 is equal to 3. And 7 times 2 is equal to 14. So as you can see, once again, we get the same answer. So if cross-cancelling looks better, looks quite easy to you, then please use that. If it looks a little bit complicated for now, then you can just times your numerators times your denominators, but then you must make sure that you simplify your answer because you might get part marks taken off if you leave your answer unsimplified. So in time, you do need to get used to cross-cancelling because it helps you hugely with your simplifying at the end. Right, let's have a look at 2 and 2/3 multiplied by 1 and 3/8. So what we need to do here is we cannot multiply with mixed numbers. So we have to convert these mixed numbers into improper fractions. So we have 2 times 3 is 6 plus 2 is 8, so we've got 8 over 3, which is equivalent to 2 and 2/3. Then we're going to multiply that by 1 and 3/8 as an improper fraction, which is 1 times 8 is 8, 9, 10, 11 over 8. Right, so as you can see here, this is quite a nice one to simplify and cross cancel. So we can see that 8 and 8 will obviously fit into both of those 8s once. And then with our 3 and our 11, we cannot simplify or cross cancel because 3 and 11 do not have a common factor. So 1 times 11 is 11, and 3 times 1 is 3. So we end up with an answer of 11 over 3, and it's probably just safe to convert this improper fraction into a mixed number. So 3 fits into 11 3 times 3 is 9. The difference between 9 and 11 is 2. So we've got 2 over 3. So 2 and 2/3 times by 1 and 3/8 is equal to 3 and 2 over 3, or 11 over 3. So it is very important when we are multiplying with mixed numbers to remember to convert them into improper fractions before you start multiplying. When we are squaring a mixed number, all we need to do is rewrite it. So we know that any number that has been squared is just that number multiplied by itself. So 2 and a quarter squared is equal to 2 and a quarter times by 2 and a quarter. Right, and because we are now working with mixed numbers, we know that before we multiply, we need to convert those mixed numbers into improper fractions. So we've got 2 by 4 is 8, plus 1 is 9. So we've got 9 over 4 times by 9 over 4, because these two numbers are exactly the same. And then all we need to do is check whether we can cross cancel. So 4 and 9 do not have a common factor, so we cannot simplify or cross cancel. And so we just multiply our 9 by 9, which is 81, and our 4 by 4, which is equal to 16. So we end up with an answer of 81 over 16. And if we would like to convert our improper fraction into a mixed number, we can, which is probably a good idea. So let's try 16 by 5 to see how many times 16 fits into 81. So 5 times 6 is equal to 30. 5 times 1 is equal to 5, plus 3 is 8. Right, so that's as close as we can get. So 16 fits into 81 5 whole times, which is 80, and the difference between 80 and 81 is equal to 1, so we've got 1 over 16. So 2 and 1/4 squared is equal to 5 and 1/16, or 81/16. Nine over 10 divided by 1 over 2. Now when we are dividing with fractions, we first need to make sure that our fractions are either common fractions like 9 over 10, or they are in the improper form, so not the mixed number form. So we've got 9 over 10, but we need to convert our 1 and a half into a mixed number. So 1 times 2 is 2, 2 plus 1 is 3 over 2. So now we've got 9 over 10 divided by 3 over 2. And when we are dividing with fractions, what we need to do is actually convert the division into a multiplication. And we are able to do that when we keep the first fraction the same, and then we put our multiplication sign in instead of a division sign. And then we flip the second fraction. So we swap these two numbers around, so the 2 becomes our numerator and the 3 becomes our denominator. And now we just work with our multiplication as usual. So we cross cancel where possible. So 10 and 2 have a common factor of 2. So we divide 2 by 2 to get 1. We divide 10 by 2 to get 5. We look at 9 and 3, which have a common factor of 3. So 3 into itself once, 3 into 9 3 times. So we end up with an answer of 3 over 5, because 3 times 1 is 3, 5 times 1 is 5. So 9 over 10 divided by 1.5, or 9 over 10 divided by 3 over 2 is equal to 3/5. Right, let's have a look at another example. 3 over 7 divided by 9 over 12. What we need to make sure of is that each of our fractions are in its simplest form. So 3 over 7 we cannot simplify any further. So 3 over 7 is fine. But 9 over 12 can actually be simplified because we know that 3 fits into both 9 and 12. So 9 divided by 3 is 3. And 12 divided by 3 is 4. So 9 over 12 is equal to 3 over 4. 3 over 4 is just its simplified version. Right, now we are going to be multiplying. So we keep our first fraction exactly the same, and we flip our second fraction so that our denominator becomes our numerator and our numerator becomes our denominator. So we end up with 4 over 3. So 3 over 7 multiplied by 4 over 3. We can now cross cancel. So we look at our 7 and our 4. There are no common factors between 7 and 4, so we cannot cross cancel there. But we can cross cancel with our 3's. We can divide them both by 3 to get 1. So then we say 1 times 4 is 4, and 7 times 1 is 7. So we end up with an answer of 4 over 7. So 3 over 7 divided by 9 over 12, or 3 over 7 divided by 3 over 4 is equal to 4 over 7. If I was asked to order these fractions in ascending order, what I need to do before I start comparing each of these fractions is to find a common denominator for all of them. So we need to find a LCM for 2, 4, 5, and 10. So we will find that 20 is our LCM for all 4 of these numbers. So 20 will be our denominator for each of these numbers in order to compare them. So I multiplied 10 by 2 to get 20, so I multiply my 3 by 2 to get 6. I multiplied my 5 by 4 to get 20, so I multiplied my 2 by 4 to get 8. I multiplied my 4 by 5 to get 20, so 3 by 5 is equal to 15. 2 times 10 gave me 20, so 1 times 10 is 10. And now I can compare my numerators. So as soon as I've got a common denominator, I can compare my numerators. So I know that 6 is my smallest fraction, so 6 over 20 is my smallest fraction. Then I've got 8 over 20, then 10 over 20, then 15 over 20. So when I am ordering my fractions and in my final answer, I have to give these fractions and not the fractions that I created, the unsimplified fractions that I created, in order to just show my working out. So these fractions out of 20 are not simplified, so you should not put them in your answer. that was more just to show how we got to our answer and to show our working out. So we would end up putting we would be putting 3/10 first, because 3/10 was our smallest number, our smallest fraction. Then we've got 2/5 was our next smallest number. Then we've got our 10/20, which was 1/2. And then we've got number 4, which is 3/4, or our 4/15. Right, let's have a look at another way of comparing our fractions. So we can convert our fractions into equivalent fractions with a common denominator, and then we can compare our numerator like what we did up here. But what we can also do is we can convert each of those fractions into decimals and then compare those decimals. So 1/2 is equal to 0.5 as a decimal. 3/4 is equal to 0.75 as a decimal. 2/5 is equal to 0.4 as a decimal, and 3/10 is equal to 0.3 as a decimal. So if you are wondering how I got there, so if we have a look at 1/2, 1/2 is equal to, we want to get it to an equivalent fraction out of 10, so I multiply my 2 by 5 to get 10, so I multiply my numerator by 5 to get 5. So that's 5/10, which is 5 divided by 10, so I bring in one decimal place, which is 0.5. So 0.75, how did I get there? From 3/4. So 3/4 is equal to 75/100, because I multiplied both my numerator and my denominator by 25. So I've got 75/100, which is 75 divided by 100. So I can just bring in 2 decimal places, which is 0.75. Let's change our color. So we've got 2/5 is equal to 4/10. And 4/10, we bring in 1 decimal point because it's 4 divided by 10 to get 0.4. And 3/10 is already out of 10, so we just bring in 1 decimal place and we get an answer of 0.3. So then we can put in some placeholders here so that each of our decimals have 2 decimal places. And then we can look at these numbers: 50, 75, 40, and 30. So even though it's actually 0.50, 0.75, 0.40, and 0.30, because each of our decimals have 0 units, we can just have a look at the tenths and the hundredths. So we can see that 0.30 is our smallest. Then we've got 0.4, then we've got 0.5, and then we've got our 0.75. So as you can see, the order is exactly the same. It's just a different way of working it out.